process by which a metal is simultaneously deformed and strengthened below the recrystallization temperature. The deformation occurs by putting a sheet of metal through a machine with two rotating cylinders that have a gap that is slightly less than the thickness of the original metal sheet. The rolling process elongates and rotates the grains of the metal in the rolling direction, which increases the number of dislocations. The dislocations are line imperfections that disrupt the perfect arrangement of atoms in the crystal structure and impede slip. The increased number of dislocations increases the length and hardness, but ductility and toughness are decreased. Cold working also causes the development of residual stresses that may not be desirable for certain applications. Cold working produces a sheet texture of the material, which results in anisotropic behavior, meaning the metal will have different properties in different directions. Cold working also reduces the corrosion resistance and electrical conductivity of the material.
Annealing is performed through the heating of a metal above its upper critical temperature for a suitable amount of time, and then allowing it to cool while still in the furnace. This process is performed in order to release internal stresses that are formed throughout manufacturing processes.
Wow, I wish I could be annealed during finals week.
And results in a material that has an increased level of ductility as well as a decreased level of brittleness. During this process, grain size increases and the number of dislocations present in the material before annealing begin to diminish. The diminishing of these dislocations occurs due to the increased movement of atoms resulting from the energy that the heat provides these atoms. This movement acts to redistribute and decrease the number of dislocations. Annealing at a low temperature may be used to eliminate the residual stresses produced during treatments such as cold working without affecting the mechanical properties of the finished product. This process is also useful for the creation of a material that is easier to shape and work as desired.
H-hardening is a heat treatment process that involves heating the metal to a temperature above the solidus line on the phase diagram. After a period of time, the heated metal is removed from the furnace and quenched rapidly to cool the metal. In doing so, the quenched metal becomes a supersaturated solid solution. This supersaturated solid solution is then placed back into the furnace to be reheated, but this time at a lower temperature than the solidus line. In doing so, the supersaturated solid solution allows for the formation of precipitate particles. These particles then make it more difficult for slip to occur, which results in a higher tensile and higher yield strength for the material.
AQT stands for austenization, quenching, and tempering. Austenization is part of the annealing process, and it is the heating of the metal to change the crystalline structure of the metal. Quenching is the rapid cooling of the metal, which increases the strength while decreasing ductility because it traps precipitate of the alloying element in a supersaturated state. Tempering is the heating of the metal, which increases toughness by dispersing the alloying element into solution with the rest of the metal. For steel, the precipitate that forms on the surface of the metal after austenization is called austenite. Depending on the rate of cooling, the austenite can be formed into three different phases. If it's cooled slowly, it's perlite. If it's cooled moderately, it's bainite. And if it's rapid quenched, it's martensite. In this form, the steel is reheated to form tempered martensite.